All right, class, section 1.6, classify polygons. So first, what is a polygon? A polygon is a closed figure that lies in a plane. So think any figure, however many sides it has, it's all closed. There are no openings. So the rules are three or more lines or line segments that make up your sides. 3 or more line segments. Number 2, each side intersects exactly 2 sides, one at each endpoint. And 3, each endpoint is called a vertex. Each endpoint is called a vertex. Convex. Convex means no line that contains a side has a point in the interior of the polygon. So if I could have a triangle. A triangle is convex. There is no point on the interior. I could have a 4-sided figure like a square. That is convex. However, I could have, that's not a very good figure, a 4-sided figure like that. That does not work. It has a point on the interior. So concave is the other. Concave is a polygon is concave if it is not convex or it caves in. So, like that other image I drew, it caves in, it's got a point on the interior. That would be a concave polygon. So concave has a point or a vertex in the interior. An equilateral polygon. All sides are congruent. So if we have a triangle, it is equilateral if all sides are the same length. All sides congruent. Same with a square. All sides are the same length in a square. That is an equilateral polygon. A rectangle would not. Equiangular polygon, like it sounds, all angles are congruent. So remember our symbol for congruent angles is just a little arc. So that triangle would be equiangular. Now we don't have the tick marks for the sides being congruent, so we can't say the sides are congruent just because the angles are. Or if we had a square, and in this case a rectangle would work too, they'd all be 90 degrees if there was a square or a rectangle. But all angles are congruent in an equiangular polygon. A regular polygon is when all sides and all angles are congruent, and it must be convex. If it was concave, the angles would not be congruent, even if the sides were. So a regular polygon has all sides and angles congruent. Or maybe you have a pentagon. You might have a regular pentagon with all sides and all angles congruent. But it must be concave, no points pointing inward. So let's name the types of polygons. If you have a 3-sided figure, it is a triangle. If you have a four-sided figure, it is a quadrilateral. That could be a square, it could be a rectangle, it could be this little shape that I drew before. It's got four sides, it's a quadrilateral. Five-sided figure is a pentagon. Again, it just needs to have five sides. It could be concave or convex. There could be a point pointing inward. Six is a hexagon. I'm going to stop drawing those as it gets more difficult with more sides, but you can draw those out. Hexagon has 6. Heptagon has 7. 8-sided figure is an octagon. 9-sided figure is a nonagon. 10-sided figure is a decagon. 12 is a dodecagon. And any other number, say an 11-sided figure, you would call that an 11gon. So the actual number 11gon. So fill in whatever number for n and just add in gon at the end of it. They probably have a name, but for our purposes, anything that's not 3, 4, 5, 6, 7, 8, 9, 10, or 12, just write in the number and put gon at the end of it. Now you do need to know that, say, 7 is a heptagon. On the test, you cannot put 7 gon and get the answer right. You need to write in heptagon. So for the ones that we give you a name for, you need to use that name. All right, so some examples. We want to tell whether the figure is a polygon and whether it is convex or concave. So the first one, letter A, is it a polygon? Think about that for a moment. Okay, your response should be yes, it is a polygon. It is a closed figure. The number of sides, all sides come to a point, a vertex. Is it convex or concave? Remember what convex means? Remember what concave? Concave is caving in. So our point here that points in means it's concave. All right, so for B, I went ahead and answered no, it is not a polygon. It is not a polygon, but also don't worry about answering convex or concave. Getting into those explanations can be kind of tricky. So then C, is C a polygon? So we've got a closed figure. However, we have this line segment going right through the middle. And because it is going through the middle, it is not a polygon. So we are not, it is not concave or convex either. Now the top half, if the top half were, say, separate, that is a polygon. The bottom half were separate, that would be a polygon. And both of those would be concave. But the entire figure of C is not a polygon. Okay, and then D, is D a polygon? Yes. And it's actually a pentagon. It's a pentagon, it's got 5 sides. Is it convex or concave? Do all the points go out, or do any of the points go in? It is convex. Next, classify the polygon by the number of sides. Tell whether the polygon, go ahead and underline that, the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. So if it's equilateral, equiangular, or regular. And then we need to explain our reasoning. So the first one, letter A. We have a rectangle. We can see that this side and this side are congruent. And these two sides are congruent. But they are not congruent. The green sides are not congruent with the red sides. They do have congruent angles. They're all 90 degrees. You can see those by those little squares there in the corners. That tells us they're 90 degrees. So it is equiangular, but it is not equilateral. So it is equiangular. And we also need to determine what it is by the number of sides. So our number of sides tells us it's a quadrilateral because it's got 4 sides. It's a quadrilateral. It's equiangular. And then our reasoning was the angles are the same, but the sides are not congruent. So you could just say angles are congruent. And I'm just going to use the little congruent symbol instead of writing it out. Then B. All right, B, we have, let's classify by the number of sides. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So that is, if you look on your paper, an octagon. So we have an octagon. Look at all of our sides to determine if it's equilateral. So see that they're all congruent sides. So that is equilateral. Is it equiangular? We can look at all the angles. We can see all the angles are congruent, so it's equiangular also. So if it's equilateral and equiangular, it is regular. So this is a regular octagon. And it's regular because sides and angles are congruent. Sides and angles are congruent. Then if we look over at our triangle, now it's got the congruent marks on it, but notice this mark only that side only has 1 mark. And this side has 2 tick marks. This side has 3 tick marks. So they're different length sides. So even though they've got the little tick marks there, there's none that match up with each of them. So none of those sides are congruent. So it is not equilateral. And then if we look, we have the same thing with the angles. That's got 1 arc. This one's got 2 arcs. That one's got 3 arcs. None of the angles match up, so it's not equiangular either. So all we have is just a triangle. And then I would answer none. It is not equilateral, not equiangular, and not regular. Just none.